Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the third part of the proportion topic where we're looking at inverse proportion but in a slightly different context. You don't technically need to have seen any of the previous videos to understand this one. This one's kind of an additional one, so let's just get straight into it. The type of question I'm talking about when I say worded inverse proportion, it's not the worded scenario ones we saw at the end of the last video. It's actually ones where they don't really mention a proportion relationship. You kind of just have to figure it out for yourselves. It kind of sneaks up on you a little bit, and a lot of people find it really hard to figure out the actual answer. But I really want to get you to understand that when you read these types of questions, just think immediately inverse proportion, okay? So let's actually look at the questions first. For example, we've got here, it takes 3 builders 4 days to build a roof. How long would it take for 6 builders to build the roof? Okay, now our immediate thought here is you go, well, if it's 3 builders and then 6 builders, that's double the amount of builders, so then it's just 8 days, right? I feel like a lot of us fall into that trap. We go, right, so I've times the builders by 2, so I'll just times the days by 2. But think about it logically. If I have more people, if I have more builders working on the same amount of work, the same roof, ideally, hopefully, it should be shorter, shouldn't it? It should take less time. That's why it's inverse proportion. Because in this example, the more builders I have, the fewer days it should take. So both of those variables, the builders and then the days, are going in opposite directions, aren't they? If I have fewer builders, it's going to take more days. So that's where a lot of people kind of go wrong. So, I mean, this one's a little bit nicer because obviously 3 and 6 are, one's multiple of the other. But the way that I would work out, let's say if they're more complicated, is, okay, well, if I've got 3 builders, takes 4 days, I would like to work out, first of all, how long does it take one builder? And again, naturally, you're going to go, yeah, I just need to divide like 4 by 3. But no, it's inverse proportion. We need to do the opposite. If I've only got one builder, it's actually going to take 3 times longer, isn't it? So in order to find, in this particular example, obviously one builder, you have to do 3 times 4. Okay, so it's actually, it would take 12 days for if I had only one builder. Now, how long does it take for 6 builders? This is when I can actually then divide it, right? Because it's going to be more builders, so therefore a short amount of time. So 6 builders would be the 12 days divided by 6, which is 2. So we get 2 days. Obviously, I've kind of gone around the houses with this explanation. The numbers here are a little bit easier for you to just think, oh yeah, I could probably just half the 4 because I've doubled the 3. But it's just so that when we go through the next few examples, or if you do get numbers that aren't related, like 3 and 6, you know exactly the method. Okay, so find out how long it takes for one builder. In this particular example, it's a builder, by timesing, and then divide to find the actual number that they want. Now, often this question is asked with a part B, which says something along the lines of, what assumption did you make when you made your estimate? It's pretty much always the same answer, obviously just relate it to the context. We assumed that each builder works at the same rate. Okay, so it's something about the same rate. So just apply it to the context. In this case, the builders worked at the same rate. Because obviously, technically in real life, you can have one builder that's a lot more productive or a lot faster than another builder, so you might end up having more builders, but some of them might not be very good, so then you end up not having it take that many days less. Okay, so just basically write down, whenever it says what assumption did you make, relate it to the context, but say something along the lines of, we assumed that everything was at the same rate. So now let's have a look at another one. It takes 5 taps 30 hours to fill a swimming pool with water. How long would it take for 2 taps to fill the pool? So again, you kind of think, oh, okay, these aren't, necessarily related in terms of, 5 is not a multiple of 2. It's a little bit more complicated than that. But you think, oh, well, it's, the number of taps has got smaller, so the 30 hours should get smaller. But no, right? If you've got fewer taps but the same swimming pool, it's going to take longer, isn't it? It's going to go the opposite direction. So I want to do first to find out how long would it take if I had only 1 tap to fill the pool, and that's when we do our multiplied. Remember we said in the previous one, 5 taps would take 30 hours, so 5 times 30 gives me 150 hours. So if I only had 1 tap, it would take 150 hours. I actually have 2 taps though. So then I can do the 150 divided by 2, which gives me 75 hours. Okay, that's why we have this kind of method, because the previous one was a little bit more simple to figure out, but this one is a little bit harder, I feel like, to work out the numbers because they're not multiples of each other. Again, what assumption did we make? In this particular context, we assumed that the taps, you could say something like the taps fill up the swimming pool at the same rate, or the water comes out of the taps at the same rate. Do you see what I mean? So it's something about the same rate, but to do with the taps or the water. Okay, so we have fewer taps. It's obviously going to take longer than 30 hours. Hopefully by now you've kind of got the gist of it. Hopefully in the exams you'll be able to recognise these questions, because I think they are very similar. It's just obviously the context is different. So if you feel like you've got the idea of it, pause the video, give this one a go. So in this one we've got, it takes 20 machines 8 hours to produce all of the bottles. How long would it take for 16 machines to produce all of the bottles? So same number of bottles, we don't really care how many bottles there are, right? It's just the same number. We had 20 machines, now we have 16, so I'm assuming it's obviously, because it's inverse proportion, they're inversely related. It's going to take a little bit longer than 8 hours, isn't it? So what we're going to do is, okay, 20 machines take 8 hours, so how long does it take for one machine? Right, so I need to do 20 times 8. So always start off by multiplying them. 20 times 8 is 160 hours. And then, okay, well, I've actually got 16 machines. So now I can divide the 160 hours by 16. That means 10 hours. It's technically like 10 hours per machine, but obviously the machines are all working at the same time, aren't they? They start at the same time in the morning. Okay, what assumption did we make? In this context, we're assuming that all the machines produce bottles at the same rate. Okay, so literally it's the same rate, but just relate it to the specific context. So 60 machines is taking us just a little bit longer to make all the bottles. Okay, final question. Give this one a go yourselves. Same exact method, and see what you can say for the part B assumption question as well. So it takes 6 decorators 60 days to paint a school. How long would it take for 8 decorators to paint the school? Okay, so I think, now that we've got the hang of it, I've got more decorators, so hopefully it will take fewer days, right? So how long would it take for one decorator to paint the whole school? Well, that's 6 times 60, which is 360 days, basically a year actually. Then we actually have 8 decorators in this case, though, don't we? So if we have 8 decorators, how long would it take? Well, you do the 360 divided by 8, which gives us 45 days. So you can see it's a little bit shorter, isn't it, than the original 60 days. Again, what assumption did we make? We are assuming that all the decorators work at the same rate, or all the decorators paint at the same rate, something like that. So that's a really quick video on that type of question. They never mentioned the fact that it's called inverse proportion, or that it is related to inverse proportion, but really, logically it is, isn't it? So just be aware that that might come up earlier on in your paper. A lot of people get it wrong, but it could be some nice easy marks to get now that you know what to do. So thanks for watching this video. Hopefully it's been helpful. Leave any questions down below in the comments, and don't forget to subscribe.